Okay, so we're going to be talking about graphs of functions. So we're going to use this graph at the bottom to find the domain, the functions of the values f of -1, f of 2, and the range. So remember, the domain is all of the x values that are encompassed in your graph. In other words, how far from the left, how far to the right. So if you look at your graph, the farthest left that this goes is right here, correct? And that is a value of -1. Notice it's a closed circle, so when you answer about your domain, you will put a bracket and then your x value of -1, comma, then this graph goes all the way and then stops right here. So this is as far to the right as it goes. So it goes all the way to 4, but it's an open circle, so that means you need to put a parenthesis to signify that that is not included in your domain. All right, part B. It wants the function values of f of -1 and f of 2. That just means when x is -1, what is y? So if I go over here, here's my x value of -1. I go to my graph, and the y value is -5. So that would equal -5. It's the same thing as if I would have had the equation for this, and I plugged in -1, I would get -5. So same thing for 2. When I go to my x value of 2, the y value is 4. All right, range is all of the y values that are encompassed in your graph. So you always go bottom to top. So the lowest that this graph goes is right here, which is -5, and there's a closed circle, so I'll put a bracket, -5, comma. The highest that this graph goes is right here. That's a y value of 4, and that has a closed bracket, or a closed circle, so you'll have a bracket. All right, number 2, find the domain and range of f of x equals the square root of x minus 4. Now, since we're focusing on the graphs, we are actually going to graph this in the calculator. All right, so we're going to take this equation, which is square root of x minus 4. Now, if I was solving for y and I had to square root in the equation, I would do the plus or minus. But since this already has the square root in it, you're just going to do the positive root because they didn't signify both. So I have the square root of x minus 4. The square root x minus 4. So it's literally just going to be half of a sideways parabola. All right, so when we talk about domain, you're talking about how far to the left does this start. So if you're looking at this right here, there's no graph, no graph, no graph, no graph. My graph starts right here. So I'm starting at 1, 2, 3, 4, and then my graph is going to go. Now remember, this just cuts off the window. If I zoomed out, this would continue going. So this keeps going this direction. So I start at 4 and go all the way to positive infinity, right? And I'll write this down on this part in just a minute. But on that page with the question, go ahead and put that your domain is 4, comma, positive infinity. And remember, infinities always have a parenthesis. Now for your range, that's how low. So this graph starts right here, which is a y value of 0. And it's going to go and keep going up and up and up and up and up and up gradually. So we'll say positive infinity. So my domain, x values, left to right, starts at 4 and goes to positive infinity. Range, how low, starts at 0, goes to positive infinity. Okay. 4 to infinity and 0 to infinity. And if you actually think about that, if I plugged 4 in for x, because that's my domain, right? 4 minus 4 gives me 0, correct? And then I want to plug in numbers that are bigger than that. 5 minus 4 gives me 1, but nothing smaller, because 3 minus 4 gives me negative 1, right? And then your outcomes come from this. So when I plug in 4, 4 minus 4 gives me 0. The square root of 0 is 0. That's my first y value. Okay. All right. Use the vertical line test to decide whether each graph represents y as a function of x. So in other words, if I look at this, if I draw a vertical line, I'm going to hit at 2 spots, correct? That's a big no-no. So this one is no. But if you look at this graph, it doesn't matter where I draw a vertical line. I'm only going to hit this graph one time each time. So this one is yes. All right. This is on page 31 in your book, but I stuck it in here in the notes. So we're talking about increasing, decreasing, and constant functions. So a function f is increasing on an interval when, for any x1 and x2 in the interval, x1 is less than x2. So in other words, here I have 1, and here I have 3. When I plug in this one, I'm down here, right? When I plug in 3, I'm up here. This is obviously increasing, correct? All right, I'm decreasing, all right, on an interval when for x1 and x2 in the interval, x1 is less than x2 applies to when I plug in the first one, it's bigger than when I plug in for the second one. So you have something like this, right? Or like a curve and it's going down, okay? It is constant for when any x1 and x2 on the interval, when I plug in that x and I plug in the second x, I get the same thing. So that's just a flat line, right? We call that constant. So when you're looking at these, it says determine the open intervals on which each function is increasing, decreasing, or constant. So if you're looking at this graph, I am increasing. Now I'm talking about from left to right. Okay, I don't use my y values. So I'm coming along here. This is coming along. It's increasing until it gets to 0, correct? When it gets to 0, then it starts increasing again. So actually, I am increasing and increasing. This is not constant because it's actually just crossing and going up. So this would be increasing it would say from negative infinity all the way to positive infinity. Okay, part B. So it looks like I'm coming along. This is increasing to here, correct? And then I'm decreasing until I get to here, and then I am increasing again. So let's start with the parts where you're increasing. Now, on these, you never use brackets because you don't know if this spot is just where it changes, correct? So you're not really including anything. This isn't domain and range. So you're just using parentheses to indicate those intervals, but you don't use any brackets, okay? All right, so I am increasing from infinity, negative infinity, right, all the way until I get to the x value of negative 1. Because remember, this is going to keep going left and out, right? So negative infinity all the way to negative 1. And then we'll do this decreasing spot in a minute. So this decreases until you get to an x value of 1, and then it increases the rest of the way. So from 1 all the way to infinity. But you do have a little spot where you are decreasing. You are decreasing when x is negative 1 all the way until x is positive 1. So you would just say negative 1, comma, 1. And remember, no brackets when you're doing increasing and decreasing. Okay? Now, let's look at this one. We're increasing until we get to an x value of 0. And then it stays constant, correct? Until you get to this x value of 2, and then it decreases the rest of the way. So if you want to just put an I for increase, that's fine. So for increasing, that would be negative infinity all the way till we get to 0. I'll put a C for constant. Then your constant, or flat, all the way from 0 to 2. So 0, comma, 2. And then you are decreasing from that x value of 2 all the way to negative infinity. Or positive infinity, sorry. To the right. Increasing all the way this direction. Decreasing. Okay. All right. Relative minimum and maximum values. Approximate the relative minimum of the function given by f of x equals 3x squared minus 4x minus 2. So remember that minimums and maximums are the curve points on your parabola where they turn, right? So like if you have a thing, this up here is your relative maximum, right? And this would be your minimum. So sometimes a graph curves a lot, right? So you would have both, okay? But it says approximate, so we're not actually going to come up with it using the formula. We're actually going to graph it and then approximate it by using buttons in the calculator, okay? So it actually makes it really nice. So if you need to write down what the steps are, then you can. All right, so we've got 3x squared minus 4x minus 2. And we'll just go ahead and graph that so we can look at it. All right, so we have a relative minimum right here, correct? So what we're going to do is we're going to have our calculator tell us what that spot is. So on the calculate menu, which is in blue right above trace, you're going to press the second button and trace. And then you have your two options here. You have minimum and you have maximum. We want it to calculate the minimum, so I'm going to choose option 3. Now, they ask you a few questions. First of all, you'll notice up here it tells you your equation that you're on. So if you have more than one equation inside, you'll know which one they're looking at by looking up here at this y1. So it's telling you, are you on the left side of your minimum? Are you on the left side of your minimum? If you are, then press enter. Okay, then it says, are you on the right side? Okay, the answer to that is no, because my little dude is right here. So I'm going to arrow over until I get on the other side of my minimum. And then I'm going to press enter. All right, so see how you've got the little things? You've got this side. You can't really see it because it's on your y-axis. And then you've got this dotted line. So your minimum or maximum, whichever one you're looking at, should be in between those two dotted lines. Okay? And then it says, do you want me to guess? And you're going to say yes by pressing enter. And then your thing should jump down to where the minimum is. If it doesn't, then that means that you've done something wrong. So it's telling us that our minimum is approximately at 0.66. Ooh, we'll do a 6 with a, we'll do 0.67 because we don't want those 3 6s. And then the y value is negative 3.33. So we'll just round it because we're approximating. All right, so that would be, well, oh, we should probably state that we have a minimum. So we'll do minimum negative, was it negative 0.67? Positive 0.67, comma, negative 3.33. 3.33. All right, are we good there? Make sure you close that because it's a point. Okay. All right, approximate the relative minimum and relative maximum of this function. Now, this is a cubic. So remember, the last one was quadratic because it had the squared was its biggest power, right? So that makes the U shapes. When you have a cube, it, sometimes it's like swirly, like a snake kind of. All right, so you could have more than one because sometimes, they're like this. All right, so we're going to graph this. Negative x cubed plus x. It's always important to make sure you get everything written typed correctly in there. Okay. All right, so if you look at this, you have two, correct? You have a minimum right here, and then you have a maximum right here. So you're going to have to do both of them. So you'll have to do the calculator stuff twice. So let's start with our minimum. So I'm going to go to calculate. I'm going to calculate the minimum, which is option 3. Now this says, are you on the left side? I am not on the left side of my minimum. So I'm going to arrow my spider guy over. Make sure you're really on the left. Press enter. And then I'm going to have to take him over to the right side and press enter. So I've got my two lines around that, correct? Press enter, and it should pop down there and tell you that the minimum is negative 0.58 for the x and negative 0.38 for the y. So for your minimum, negative 0.58 and negative 0.38. All right, and then we also know we're going to have a maximum. So you're going to do the same thing, but instead of choosing for your calculator to calculate the minimum, you're going to choose maximum. So same thing, it's going to ask you the same questions. Are you on the left side? I like to get, like a little bit closer, but I'm going to press enter. I'm on the left, and then it says, are you on the right? I'm not, but I'm going to move my little guy to the right. Press enter, and then have it guess, so press enter. And notice it pops up on the top there. So your maximum is 0.58 and 0.38. So it's like equally distant from the bottom to the top, right? So 0.58, comma 0.38. All right. During a 24-hour period, the temperature Y in degrees Fahrenheit of a certain city can be approximated by this model. Now, notice that X is between 0 and 24. That's because there's only 24 hours in a day, right? Where X represents the time of day with X equals 0 corresponding to 6 a.m. So if I plug in 0 for the X's, then that's going to give me the temperature at 6 a.m., right? Approximate the maximum temperature during this 24-hour period, okay? So if we want to approximate the maximum, we can graph this, right? So we're going to do the same thing that we have been doing. I've got 0.026 x to the third. And remember, make sure after you do those exponents, you pop back down. Minus 1.03 x squared plus 10.2 x plus 34. All right, so we're trying to find the maximum, what was the question? Approximate the maximum temperature, okay? Temperature is the y, correct? All right, so this is going way up there where we can't see it, correct? That's because the temperature is going to be more than 10, right? Okay, when this yellow thing goes away, then you're done. All right, so let's see here. Zoom. There is one that will take you to where your graph is at. I think it's 9. Let me see. Okay, it's not 9. Is it Zoom Fit? Zoom. Let me look at them. Did Zoom Fit take you to the right spot? Is that the one it is? Okay. Good job, Marco. Okay, so obviously your maximum is up here, correct? And I think I'm going to actually have it zoom out just a little bit, just because I want to make sure I can really see the top of it. All right. So it looks like our temperature goes up and then goes back down, right? So obviously the temperature is not ever going to be way up that high, right? So we're looking for this maximum temperature here. So we're looking for the maximum value. There's no way we can tell what this number is, right? It's too zoomed out. So you're going to go to your calculate menu and have it calculate your maximum. And it says, are you on the left? I'm going to scoot over just a little bit just because I am on the left. And then you want to get on the right. Press enter. And then you want it to guess, so press enter. All right, and then separate. Now remember, the maximum temperature is the y value because x represents the times of your day, right? By the way, what time of day is this? If 0 represents 6 o'clock, this would represent between 12 and 1, right? Okay. It reaches 63.9 degrees. So let's just round that to an even 64 degrees. I would like to know what city this is. Right? The maximum temperature. Might be nice to live there. All right. So I added these at some point so we can talk about piecewise. So we're supposed to sketch the graph of this. Okay, so it says sketch the graph of this piecewise function. So we have two pieces. So we're just going to focus on one piece at a time. So the first one I'm going to do is 2x plus 3. Now when you have an x to the first power and no other variables, this is just going to be a line, right? And remember when graphing a line, the number with the x represents your slope, and the number with your that doesn't have an x represents your y-intercept, right? So your slope is 2 over 1, and then your y-intercept, which is your b, not your m. I'll just write y-intercept, is the 3, okay? Now, this is for all the x values that are less than or equal to 1. So this piece of the graph doesn't go past right here. Are you guys with me on this? It's this way and left. So x values of 1 and less than that. All right, now if I graph this, I start at the y-intercept, which is 3. 1, 2, 3. And I would go up to and right 1. So I start at that dot and I go up 2 and to the right 1. Now remember, that's an x value of 1 right here, correct? This graph doesn't go anywhere past that to the right. I want to make that clear. It's all x values less than or equal to 1. So I don't put anything else to the right. But I can put a few more dots this way if I go backwards and go down and left. So you can change both directions. Then you want to just draw your line in using a ruler because we all know that I'm picky about that. All right, so you're going to start at that dot, but remember you're not going past that dot that's on the right. Okay? What just happened? Okay. All right, so let me get the right line here. So you're going to start at that dot. Well, I need the other line. This one. And you're going to draw through your dots this direction and put an arrow in the end because that signifies that just keeps going. All right, so that is the piece that is on the left. Everybody with me? Okay, so let's talk about this piece. These are all the x values that are greater than 1. Okay, greater than 1. So I'm going to do the same thing. I've got the negative x plus 4. My slope is a negative 1 because that's the number in front of the x over 1. And my y-intercept is 4. Now, just for graphing purposes, I'm going to start here, but we will not connect that dot, okay? So if you start at 1, 2, 3, 4, you would be starting here, but we're going to erase that in a minute because that's not part of our graph. And I would go down 1, right 1. Now here's the thing. Pay close attention here. We have a dot here, but it's going to be an open circle because we can't have anything right here when x is 1. It's not equal to, correct? You can't have an equal to and an equal to. So that one's closed, but this one's going to be open. You always want to start there even though you really don't have a dot there. But you have everything that leads up to that, okay? And then you've got down 1 to the right 1. Down 1 to the right 1. So draw yourself a few dots. Remember, this is open. So this little piece right here, we don't need that. We just used it to help graph our line. All right, then you're going to start right there, and you're going to draw your line through your dots and extend this direction. And now you have two pieces. So I'm going to reiterate this again. This number, you have to have a dot there. Like you have to have a dot here, even though it's not included. But to show that it's not included, you put it as an open circle. So this number has a dot on both of your sides. See, I have a dot there when x is 1, and I also have a dot here. This one is closed. This one is open. But you have to have a dot there for both of them. Because it's kind of like this goes here, and you're 1, but then right after 1, like 1.0000001 is included on this side. 1.00002 included on this side. 1.1. So here's the deal. You got to include those. That's why you have to have that little dot. Okay? Okay. Even and odd functions. Oh, I do want to point something else out. If you don't, let's say that you don't have a linear equation here. What you can do is you can plug in numbers. So like start with 1 and then plug in 0. And then plug in -1 to get your 3 dots. So if I started with 1, 2 times 1 is 2, plus 3 is 5. I have a dot there. Plug in 0. 0 times 2 is 0, plus 3 is 3. I have a dot at 0, 3. And then you've got your dots, right? So you can do the same thing here. Start at 1. -1 plus 4 is 3. 1, 3, but it's open. and then pick numbers that are bigger than that. 2, 3. Get your dots so you can plug it in. So if you have an equation that's not linear where you can just do the y-intercept and the slope, then you can plug in numbers instead. All right, even and odd functions. We're going to stop here and save this for tomorrow.